Okay, hi. Today's topic will be on security penetration testing at RTL level. It looks different from your schedule because I summarized the topic. It's talk about the same thing, just because the title was too long, I shortened it. Okay, for the agenda, I'm going to share about why doing penetration testing at RTL level. And then next, I will talk about how to do penetration testing at RTL level and how can you apply this. So on the first agenda, why doing penetration testing at RTL level? So let's look at the product life cycle. We have for the product development, we have multiple phases. First is the exploration phase, and then the planning stage, and then development stage, and then finally the production stage. For each of these stages, there is a lot of engineering activity, and is to ensure the success of the product. And basically, I'm going to focus on the design and validation, which they started not long after the exploration phase. The design starts with architecture design, and then move on to architecture simulation. And then on the validation side, they will start with the planning. As the time moves on, we were going to have the design, getting the RTL code ready. And then the pre-silicon validation is going to start validating on this RTL code. And as time moves on, we go to schematic and layout, and then we finally tape out the product. And it was at this time the post-silicon validation start. And they will be very busy when the silicon come back, and they will do all the testing, run all the tests, make sure that they catch all the bugs before the next stepping, so that if there is any bug, we can get it fixed in time. And then we will launch a product, and there's an end of life of the product. So where is this penetration testing come into this picture? Normally, we do penetration testing at silicon, when the time silicon is back and before the next stepping. So this is a relatively short time in this whole product life cycle. With that, we encounter several issues during the pen testing at the post-silicon stage. Because it's a very short evaluation time, we don't really have enough time to do all our testing. And we decided that we need a new methodology. And before we define a new methodology, we need to set up a new requirement for our methodology. So due to this short evaluation time, we require that we want to find the security vulnerability early, meaning that we want to find it before the silicon come back. And the next issue we have is we depend a lot on the silicon and firmware, which are always delivered late at the point of the time then after this after tape out. It's a schedule we can never have it early, and our testing methodology rely on the silicon, and which is come together with the platform, and we need a firmware that run on it. So we can not do the testing earlier because of the need that we have. And so we set up that in our new methodology, we require that a method that independent of firmware and silicon. And the next issue we have is if we ever find any vulnerability in our evaluation at this stage of time, we may require fixes that is very difficult to put in. Sometimes we may find the vulnerability just before the next stepping going to tap out. So in that way, sometimes we require another stepping just to fix the vulnerability. So it becomes that very expensive for us to fix it in the hardware. So in our new requirement, we want that to find defects when they are very easy to fix. So with that, we propose a new methodology. Our proposal is to perform the pen testing at RTL level, which is at the pre-silicon phase. And we want to reuse the pre-silicon validation methodology and tools because it's convenient. Since we are doing the testing at the same time as the pre-silicon validation, so we decided that why not we just reuse their methodology and tools. And we found that with this new methodology, we can meet the requirement that we set earlier. As it can start as soon as RTL design is ready, which is very early at the stage that at the development stage. And this is a methodology that commonly used to validate the hardware, and they are independent of the firmware and the silicon. And we want to find bugs when they are easy to fix. So how do we do the pen testing at RTL level? We have the pre-silicon methodology to do our security testing, but can we just apply it directly? Of course, there are some differences, different emphasis, different focus in doing validation and doing security pen testing. So how are we go about it? So first of all, we look at functional validation. In the functional validation, we normally have an RTL model. So in the RTL model, we have RTL code, which is a design under test. And normally, in the RTL model, it comes together with this test bench. Test bench is a virtual environment to verify a design. So in the test bench, we have BFM, which is a fast functional model. It helps to simulate the behavior of the hardware system, and it could have a proper protocol defined for us to run the test easily. And we have a tracker. Tracker is it serves as an observer to monitor the traffic that go in and out from this RTL code, so that we can know what is happening. And then we have the test to generate those stimulus to the RTL model. And of course, the validation, the functional validation, their goal is to find bugs. So they run all this testing just to make sure that we manage to find the bugs. And so how security testing is different? As you can see on the functionality, in the security, there's two different directions. Functionality, if we have an unexpected functionality, it's a bonus, it's fine. But on the security side, unexpected functionality it can be a problem because hacker can use it to attack our product. So in our testing, both functional validation and security testing, our goal is different. Our goal is the same. We want to find bugs, but the difference is in the conventional validation, we want to ensure that the product works correctly. It works correctly under anticipated condition. Under security testing, we want to make sure that our design is able to defend against attack. It's like a game of chess where designer was the attacker, and attacker always get the last move. And when we have a security feature in our product, the validation team is expected to test that the feature works correctly. For example, an encryption algorithm, the validation team is supposed to make sure that the algorithm behave correctly and design correctly. But the security testing will make sure that we can defend if there is any attack. So how we do it in our pen testing and how we apply it on this security testing in the RTL level. So first, we start with a spec review, a security specification review. And then we move on to define a threat model. And with that, we put it into the validation environment. And then we will implement attacks and check, we implement our tests. And if we have any obstacle means that sometimes the design already have defenses. The architect already put in defenses. So the attack won't be very direct. So we need to overcome those attacks and need to find how to properly test it. And when we have done all this, we run the simulation. If it is failed, meaning that it failed our check. Failing check can mean a few things. It can mean that it hit the asset that we try to protect. So if it really can access to those data that we want to protect, then it definitely is a bug. So we need to fix the design, and then we need to verify the fix, and we need to go over the loop again to implement a new attack to make sure that this fix is robust. And the other thing, sometimes it failed our check, but it didn't really hit the target. So we may want to go back to the test and to tune our test to make sure that it can hit the target. And sometimes it doesn't hit the target just because the design already defends it. So we need to analyze this attack, and if the test did not fail, and after we analyze it and we satisfied that the design is robust against all the attack, we decide that we should move on to the next attack, next scenario. So let's go through each of these steps. So first of all is the security specification review. So under security specification review, normally we can find the security objective in the spec. It should stated clearly there by the architect. And we need to look for the asset, we need to look for the threat agent, we need to look for the access control. So the access is data we want to protect. The threat agent is an entry point that can exploit the asset of the system.